Okay, this recording is going to go over the answers to the quiz review questions, reviewing lessons 106 through 109, which discusses angle pairs, which is complementary, supplementary, adjacent, and vertical angles, as well as parallel and perpendicular lines, and angle and segment bisectors. Again, if you haven't done the questions, you're going to want to pause it as each question comes up, or access the questions that I sent out in the email, try to do them on your own, and then watch this recording for the explanations to the answers. So question 1, draw an example of each of the following. For parallel lines, it's really important that you show the arrows on the lines to indicate that they are parallel, so that you know that they were always the same distance apart. Perpendicular, it's important that you draw the square at the intersection of the two lines to show that they form right angles. Supplementary angles, two angles that sum together to equal 180 degrees. And complementary angles that sum together to equal 90 degrees. We don't show them here necessarily, but you could have. Or in this case, that square indicates a right angle, which means 90 degrees. So these two angles form a right angle, therefore they are complementary. So 55 and 35 degrees could be those measures. Vertical angles are when two angles intersect. They create two pair of vertical angles. 2 and 4 are vertical, and 1 and 3 are vertical. And vertical angles are congruent, which means they have the same measure. Question 2, segment BE is perpendicular to segment DF. Measure of angle DEE is 71 degrees. What is the measure of AEB? When you do these types of questions, the best thing to do is to make a highlight. So if BE is a perpendicular to DF, then you can go and you can draw a right angle to indicate that is a right angle there. Perpendicular means forms a right angle. And the measure of DEA, change the color here. DEA, that's DEA, is 71 degrees. So plug that in so you know what that means. And they want to know what the measure of AEB is. And where's that? AEB. All right. So if BE is perpendicular to DEF, this is a right angle, so is this angle over here. So DEB is a right angle. DEA, one part of that, these are adjacent angles, right? And it's the addition postulate says that the sum of the parts equals the whole. So if these both equal 90, the blue and the green, and this one's 71, then 90 minus 71 gives you 19 degrees. Question 3. Many of Manhattan's roads run either north and south or east and west. Name a street that is perpendicular to 8th Avenue. So find 8th Avenue, highlight it, and you need to find a street that's perpendicular. So if that one's running north and south, then you want to find one that's running east and west. And I'm just going to change here. So I'm just going to create a line. And I'm going to start looking. Well, here's one, 57th Street, not listed. West 42nd, that one is listed. There's also West 34th and West 23rd. But the only one listed here is West 42nd Street. So the answer to this one is West 42nd Street. Is perpendicular to 8th Avenue. Question 4. Given that TW equals 2x plus 2, and SW equals 4x minus 12, so let's mark that up. 2x plus 2, and WS is 4x minus 12. What is the value of x? So for this one, we're going to answer A, B, C, or D, find the value of x. So in order to find the value of x, I need an equation in terms of x. So I have these two terms, expressions with x in them. So if you look on the diagram, what is the relationship between those two segments? Well, they're congruent via these tick marks. So the equation we want then is saying if TW is 2x plus 2 and that equals SW, which is 4x minus 12, then the equation to solve is 2x plus 2 equals 4x minus 12. Solve the equation, subtract 2x from both sides. We're left with 2 equals 2x minus 12. Add 12 to both sides. 14 equals 2x. Divide both sides by 2. X equals 7. Now, if they asked you to find the measure of TW, and be careful on the quiz, what are they asking for? The x value or the measure of a segment or an angle, in this case a segment, then you would plug in the 7 for tx plus 2x plus 2 equals 2 times 7. 7 replaces the x. 12 plus 2 is 14. Sorry, 14 plus 2 is 16. So the measure of this would be 16 units. So if TW is 16 units, so is WS. And again, if you put in 7 here, 4 times 7 is 28 minus 12 is also 16. Question number 5. If EZ equals 20, EZ 20 units, EG equals 24 units, and FG equals 30 units, then FE is 24. So the question is FE over here 24? And the answer is yes, it is. Why? Because these tick marks indicate congruent segments. So this is 2 and this has 2, so they're congruent to each other. Down here, this one tick means FZ is congruent to ZG. For this one, though, EG is congruent to EF. So if EG is 24, then so is EF. Number 6. If EZ equals 20, this is the same number, so let's just redo it real quick. EZ equals 20, EG equals 24, and FG is 30, and then that was, again, this entire segment over here. What is the segment bisector of FG? So FG, that is 30, they want to know what segment is the segment bisector. What segment bisects this into two congruent parts? Well, Z must be the midpoint because that's where these two segments are separated. So this is the midpoint, so EZ is the segment bisector because the segment bisector goes through the midpoint of the segment, right? Two congruent parts, midpoint, EZ goes through the midpoint of that segment. So the answer to this one is ZE or EZ. Doesn't matter which way you name them. What is the measure of FZ? So now they want the measure of just this part. What's the measure of just this part? Well, if the entire part is 30, the segment addition postulate says, right, sum of the parts equal the whole. Okay, so that means both of these parts sum to 30. There's two of them, and they're congruent. So 30 divided by 2 is going to give you 15. 30 divided by 2 is 15 units. Each of these is 15 because the entire thing is 30, and they're congruent, and there's two parts, so divide it in half. The last question, name the angle bisector of angle CDA. So again, CDA, that's the angle, and they want to know which one's the angle bisector. So the angle bisector is going to go through the vertex of the angle, dividing it into two congruent parts. So if you look at that angle there, the two congruent parts are this side, ADE, and this side, EDC. So what angle is the angle bisector? It's this one right here. This is the segment. So the question is, how did they name it? It could be DE or DB. But I don't see any E's here, so they're going all the way from here all the way up to here. And so it's DB or BD. Remember, when you're naming segments, it doesn't matter how you name them. You have to name them by two endpoints. So DE is also a segment, and that's a segment bisector to this angle. But they went all the way to the other end, B here, and that is the angle bisector. So again, if you could independently answer these questions and you got them all correctly, or if you made a mistake but you understood your mistake, then you should be good to go. Make sure you've completed all your practices, 106, 107, 109. and the integration, algebra integration. If you finished all 4 of those practices and can answer all these questions, you studied your note sheet, you should be good to go to attempt the quiz. If you get any wrong in the quiz and you don't know why they're wrong, reach out to me before you take your second attempt. Or look at these review questions again to see if there's one similar from the review questions or from class that was similar to the one you got wrong on the quiz. Figure that one out and then retake the quiz.